Everybody, let's take a little bit of time going over experiment 2. This is the recrystallization experiment. So I'm in Professor Sherlock's page, and we're going to go here. You can see that this is experiment 2 here. We can see all the things that you're asked to do. Now, so it just bears repeating that we're going to write everything down in our general procedure from the directions down, and that's going to consist of our general procedure. So you're going to do this, and there's 3 parts to this experiment, much like the first experiment 1. And then you can see what some of those experiments are. But let's talk about what the purpose of this experiment is for your lab book. Okay, you're going to write a purpose for this. Okay? Much like experiment 1 was to separate liquids, recrystallization is used to separate solids. So in this case, you are going to purify, it's a fancy way of saying separate, you're going to purify 3, if I can do that, right? 3 different solids in order to try to purify those, okay? So purify 3 different solids. And the way that we're going to do this is using recrystallization. So I thought I would spend a little bit of time talking about recrystallization. And let me call up some pictures, okay? And let me also get rid of my face here, okay? And so there's really 2 steps to a recrystallization, and this is the first one. Okay, in this first step, you take the solution and you heat whatever solution you're going to use up to just below boiling. In this case, it says benzoic acid solution, but I think that you're going to be using ethanol, and you're going to be heating that up just below its boiling point. And you are going to be, in the first part, using benzyl. Okay, so you're going to be recrystallizing benzyl. Okay, now you should know what temperature the boiling point of ethanol is. Okay, you don't want to heat this up beyond boiling. Okay, the reason is that you're going to then, on the hot plate, you're going to get a separate container that's got your solid in it, and then you're going to add dropwise your solvent until this just barely dissolves. Okay, so you're going to have a container of liquid that has your stuff dissolved into it, and I say that it will just barely dissolve. That is chemically important. So if this is boiling, you're losing vapor, or you're losing solvent, and when you're losing solvent, that means that this may never get to the point where it's just barely dissolved. So you want to heat this to just below the solution's boiling point. Then what you're going to do is cool the solution down slowly. When you cool it down slowly, what's going to end up happening is that after time, okay, you started with a solution that was clear, okay, nothing in it. Then over time, as the solution cools off, because the boiling point, the solubility of something changes as something cools, eventually what's going to happen is you're going to have a pile of solid in here, okay, in your container. And that solid now will be pure. This stuff will be pure benzyl in this case, and then for part B and C it's something different. Okay, now once you have this, you've actually done the chemistry at this point. You've purified the stuff. What you need to do is you need to set up an apparatus to separate the solid, the pure solid, from the solvent, and that is used by that is done by using this apparatus here with a Buchner funnel. Okay, there should be like a little umlaut over that U. Okay, these Buchner funnels are ceramic, and basically what's going to happen is you're going to take this and you're going to run first of all, you're going to run ethanol through ethanol, if I can spell, through the filter at first. All that's going to do is make sure that that filter paper is seated or isn't going to move during the experiment. So you're going to do that, and so you're going to have a little bit of ethanol. Okay, and then afterwards you're going to take this guy with the solid in it, and you're going to put that. The solid will eventually be up here. Okay, I'm not trying to insult your intelligence by explaining to you how filtration works, but the solid is going to be up at the top. The liquid is going to be at the bottom. And that means that we can then weigh this. We can dry it because we want the ethanol to evaporate. And then we can dry it. Once it's dry, we can find the mass, and we can figure out what the percent recovery is. Percent recovery is a little different than the percent yield, but what we're talking about is how much the percentage of solid that we were able to get back out of it that is pure. Okay, I will tell you that benzyl is going to be pretty good. The amount of benzyl you get is probably going to be pretty good. Okay, so we'll see you in lab.